So guys, hey, my name is Mihails Tumkins, and I work at Chile as a iOS developer. As mentioned before, we are looking for some guys who maybe want to join us. So yeah, and today I'm gonna tell you about kind of cool framework for making the 2D game at small scale. You know, it's not big like Unity, but but it works on any Apple device, and you can achieve pretty big things with it. So it's called SpriteKit. It's around from iOS 7, based by Apple, and it's actually, if you worked with Cocos 2D, maybe anyone? Cocos 2D? Yeah. So its API is really similar. It's basically what they did, because with Cocos 2D there was problem when Apple updated their OS version. There's usually been some problem with compatibility, so Apple provided their own version of it. So it has everything you need for the 2D framework, like support for sprite, shape, particles, style maps, animation, physics. It's for a lot of those tools, it also has like visual editing. And to get started, this is the name of 6 classes you need to know. Basically, if you know them, you can do like almost like 90% of 2D game tasks. And on the top level, there's SK view, which is a snap-in replacement for UI view. And then you add a SK scene, which is kind of your game scene. It can be menu scene, level scene, like, I don't know, game over scene. And then everything else you work with is a SK node or subclass of SK node. And what you can do, you can run action on it, like fade out, rotate, scale, stuff like that. I'm just going to go through some basic nodes, some most common nodes of the SpriteKit, and then I kind of show you the demo. So on the main level, there is no SK node, which has this like properties like scale, rotation, alpha, position, and like every other like sprite or shape will have the same properties. Like sprite node will have texture and color and blending. You can get like blending factor. You can also have like shader for the sprite if you need to. SK label works with font, and API is quite similar to what you usually have in UIKit applications. SK video node is really cool. This is kind of like one line of code you need to present a video on the screen. You don't need like to mess with every players and stuff like that. You just do like video file name, add to parent scene, and it start playing. Same with audio. And like effect nodes is more something. It's not like shaders, but you still can transform the metrics of it and do some really amazing stuff with it. Emitter nodes, like for stuff like particles, for creating cool visual effects, and it has full like visual editor, which you can like tweak any parameter with, and then you will have it in your game as you see it in the editor. So with each of those nodes, you can run actions on them, and actions basically like rotate, move, fade, scale, stuff like that. But not only you can run them individually, but you can do like sequences or groups and repeat and mix it all together on the various level. Also, you have support for your custom code in those sections. And with those sections, you can like achieve really amazing results. Also, each node has support for physics. So a lot of games has physics like collision, when I know Angry Birds, the birds collide with the walls and the pigs and whatever. So you can, if you need, you can add the physics to your nodes with like no additional cost. You just add a physic body to it, and it works. So the type of physic bodies, there are dynamic, static, and edged. So dynamic bodies are like bodies which has volume and are fully connected to these physics engines, like I know, like wind, gravity, and stuff like that. Static, they still have volume, but no external forces are kind of working with them. And edged is just like for making sealed areas, can be like your world boundaries or stuff like that. And then to those physics body, you can do like two things with them. You can apply impulse or force. Impulse would be something like kicking it, and force would be something like applying the same amount of force like each frame. And they have possibility to detect collisions and contact, which one is other. Collision is something which like happened internally in the physics engine. It's so basically two bodies collide, and they need they have some frictions, they have some restitutions, they have some mass, and they may bounce some distance and stuff like that. That's handled in collision and handled internally. And there's a contact. Contact is where you can plug in your own code and do something with it. So detect if it's like connected with an enemy, then like if player connected with the enemy dies, if a player connected with a power up adds some lives or stuff like that. Also, you can assign categories. So for each node, you can assign individual category, and that means that when the other nodes will collide with it, they will check if they will have a collision bit mask to detect a collision, and if they have a contact text bit mask to detect for contact. If they're not, they will just behave like they are not physical and go through one another. And that's basically different ways of adding physics body. So we have a sprite named logo, and in the first line we're giving the body with a rectangular shape. In the second line we're giving it with a circle, and the third one is quite interesting. It will take the texture of your sprite and make a pixel perfect shape for the physics body. And for the category collision and contact bit mask, we just assigned bits to them, and it kind of works. And each scene, which is kind of container for those nodes, has a SK physical world, which is environment for all your physics, and you can control properties like, I know, gravities, wind, some maybe attraction fields and stuff like that. So in this slide, you can see like we're just giving it a vector. One is which will make your all physics bodies go down, and the other is up. So yeah, and on this scene, you can also assign it like SK physics contact delegate, and that's where you will plug in your custom code to do something after things collide. Yeah. So with that, it's here we have a full SpriteKit run loop. So it's each frame it updates, evaluates all the action, simulates physics, applied constraints for camera and stuff like that, and then it renders the view. So what's great with the SpriteKit is that that each year they have like new feature coming up. Like this year they gave us like full support for tile maps. Before that, people were forced to use external tile maps editors. Now it's built in, and they are and not only it's like regular tile maps, they can like actually animate them. The year before that, they added dynamic lighting and stuff like that. I have made some demo, which is some small game kind of kind of endless runner and Flappy Bird mix up, and I'll just show you some code in action. So here we have our regular storyboard with one label on it, and the thing is that the view is actually a SKView class, and as you see, it works as a replacement to the UI view. And in this view controller, we just create a new scene, add the handler for the update score, set the scaling mode for the scene, and present it. Then we have some features like useful for debugging, like show FPS or show physics or show like how many nodes it is. And for each scene, we have also visual file. So basically, this is what this scene will look like. It's just like black, and with anchor point all to the bottom left. So when the scene is presented, it calls did move to view, and here when the magics begin. Here we create player, sky, background, and stuff like that. Start playing music, also like SK node, add child, and it starts playing. And on the touches, we're checking for the game state and do something. Probably I'm not really good at that. So yeah, the thing is that each of those scenes with these coins and bets is not written in code, but it's written in. It's not written. It's made in the editor. So here we have our coins for one scene, and here's another encounter, and here's the third. So like if we want to add another one, we just do like SpriteKit scene. So we created a new scene, and then we can add like sprites. We can choose a texture for the sprite. Let's do coin. So yeah, here's our coin. I think our scene is a little bit too big. Let me check the sizes. Yeah. So okay, yeah. And then we can add our class to that coin. And let's just make some of them. So yeah, something like that. Here what I call like encounter manager, which is basically one function class, which loads this scene, takes all the items, and returns you a node with those items. So I think it should work. Yeah, it goes random, so it might not generate it in a while. Or maybe it just doesn't work. Oh man, I'm getting better. Come on, give me something different. So it's kind of like spinning the slots. Okay, let's do something different. I'll just, in our random, we will have random from 1. That wasn't as planned. I think something's wrong again. So what? Yeah, I think I should set it to zeros. Yep. So the anchor point was 0.5 and not 1. So let's move it. Okay. Yep, here we go. This is not the coin I expected. Okay. I really like that concept. Probably should use it somewhere. So what's happened? Why that happened? In the game scene, I didn't assign individual categories for the coins or enemies, and I just set the player to contact with everything is not player. But in the scene, I'm checking if the coin has name coin, which it obviously doesn't. So yeah, coin. Coin. I think let's leave the rest of them as not coins, just for the fun of it. Okay, let's go. Yay! And this is a fake one. So yeah. I can't get past them. So yeah, let's look at this contact thing. So when the plane and coin collide, it's called did begin method on the SK Physic contact delegate, and there we have we have a contact which is two bodies, and one of them is coin, another. No. Yeah, whatever. So yeah, and we do some logic, and then we play sound by doing action. Also, no heavy player, no loading, no stuff. Just like say play sound name whatever, and it's placed. Also, from the cool features, each of our like sprites is we have like 2 or 3 versions of them are in a separated folder, which is actually not a folder. When you work with graphics, you create a new sprite atlas and just add sprites there. And on the runtime, they will do automatically compressing and like tiling for those textures, so it wouldn't take much space, kind of like that. Here we can look at the plane. It has one animation. It has 3 frame. We create it with like first frame texture, assign a physics body to it, and then animate with these 3 textures forever. And that's all there is to it to run the animation. And when I tap the screen, I just applied impulse vertically to the plane, so it kind of jumps, kind of like that. I will put this code later on the GitHub probably, so so you could check it out and maybe mate out something with it. Yeah, also with the particles. So here's our particle, and it's black. So let's change the color to, I don't know, this one or this one or this one. So yeah, let's make it red. And if you run now, it will be red. I wonder why. Yep, red one. So there we go. Also, one thing is really cool that it's really integrate with UIKit. So in our UI view controller, we have a regular UI label, and here's the method which sets the text. And on the scene, yeah. On the scene, I just have the score handler, which takes int and returns void, and so you just assign it, and on the did set for score, it just calls it if it exists. So it's kind of, you can still do some your whatever UIKit application, like, I don't know, maybe to-do list or some sport fitness tracking app, and then add to this UI view, you're having this scene which will allows you to present some dynamic effects, kind of like that. So yeah, so like besides those nodes, there's like camera node, which if you make a level-based game, you can have camera and assign it to a player, so not to show whole level at once. You have tile maps. You have light node for dynamic lighting. It has similar API to the physics one, so you just have a light node on the scene and then assign to your other nodes which bit mask it should it have a shadow or not. It has pretty decent support for shader, and each node there actually is a property shader which has like SKS shader, and you start this shader like SKS shader from file and then give it like your shader file. Also, you can work with you can use Gameplay Kit, which is framework for Apple, works together with SpriteKit or without it. It's for making like pathfinding, artificial intelligence. They have some like pretty decent random number generation, and you can make pretty cool stuff by combining those two together. And also a Tumkins, which is a really similar thing to a SpriteKit, but for 3D graphics. It has similar architecture, but just kind of adds one more dimension to it. So yeah, you can learn the stuff by reading Apple documentation. There's really cool book from the Ray Radovich team, 2D Apple Games by Tutorials. They go through like 6 or 7 games with you. There is a SpriteKit.com, which kind of tracks all the tutorials and GitHub code examples. which use SpriteKit. And the last link here is the asset I used in this game. There's this guy, Kenny, I think he's from Netherlands. Could be, yeah. And he has a pretty decent bunch of free assets you can use in your game. If you're a beginning game developer, getting assets might be a problem if you're not a 2D artist. So you can take it just from there and use it in your game. So yeah, that's all. Thank you.